Good morning or good afternoon or even good evening, depending on what part of the world you are in. And very warm welcome to our March 2024 monthly webinars. The title of the monthly webinars today is the accelerated replacement of the iconic Nashville Broadway Viaduct Bridge. And we are very glad to have almost 700 sites that have registered to listen to our monthly webinar live. We are delighted to have with us Clayton Markham, who is with the Tennessee Department of Transportation, and Donald McCray with the Gresham Smith as two speakers to deliver this monthly webinars. During the registration process, we did receive a number of questions, and Paul and Jugesh will be moderating the question and answer period. But if you have some additional question, please, by all means, post it on the dashboard, and we'll try to get to them as time permitted. And if there is no time, we will try to, we will be posting the questions and answer to them on our website later on. Before we start the webinar, there's just a couple of very important announcements related to our upcoming conference, 2024 World Bridge Engineering Conference. Now, formerly, as you know, the name of the conference was International Accelerated Bridge Construction Conference, but because our new University Transportation Center is involved in the innovative bridge technologies, that's why we cover really all construction type, all the topics related to the bridge engineering, and that's the reason to change the name to World Bridge Engineering Conference. The deadline is April 12th to submit your abstract. You can submit your abstract online, but please, we would like to ask you that don't wait until the last minute. Submit your abstract early. That will help us. We also would like to say thank you to all the states, all the 33 state Department of Transportation that have co-sponsored the conference. The state bridge engineer or their representative of these 33 state DOTs and the Federal Highway Administration will be basically reviewing all the abstract, and they're going to assist us to set up the technical portion of the conference. So the conference is going to be 3 days. We expect large number of people to attend because the topics that we are covering this time really encompasses every topic that falls under the bridge engineering, as you see over here. So we are not just about the ABC anymore, but we are covering all construction type, all material types, and any topic that is related to the bridge engineering. We also would like to let you know, most of you know, that we are also developing travel scholarship to assist the bridge owners. These are state DOT engineers or county engineers to attend, or municipalities that manage the bridges to attend the conference. The travel scholarship will be covering all your registration, the hotel stay at per diem, and the transportation at the transportation from the airport to the hotel and the hotel back too. Now, these travel scholarships are only for the U.S. bridge owners, so we cannot support, unfortunately, the bridge owner outside the U.S. So these are only for the bridge owners that are in the U.S. We also would like to let you know that there is an opportunity. The space is limited to exhibit. So if you would like to exhibit, you can go to our website, and then there's the information there, who to contact and how to reserve your booth. Also, we would like to suggest that you reserve your hotel at the special conference rate soon, because December is a very busy time in Miami, as you expect, because of the weather and so on. So the sooner you reserve, the better chance you have to reserve your rooms at the special conference room. So if you just go to our website, go to the conference page, on the left-hand side, you will see that it says housing, And if you click on the housing, it will take you to the hotel website, and that's how you can reserve your, basically, the room. We also would like to help from our audiences to spread the word. Please share the information about the conference, about the call for abstract, the deadline being April 12, with other bridge professionals. You can share the website, you can share anything that you wish, and just to spread the word. And the barcode that you see, the QR code that you see down there, will take you directly to the how to submit your abstract. So at this point, I'm going to turn it to Kathy, who is going to share with us some additional news related to the bridge engineering before we proceed with the presentation. Kathy, it's all yours.
Thank you, Torad. Thank you all for joining us today for what's our 156th monthly webinar. Before we get started with the webinar, I'll go ahead and go through some other industry news. First of all, we have the National Concrete Bridge Council in cooperation with the Georgia Department of Transportation and the Federal Highway Administration. They'll be presenting a seminar on pre-stressed concrete bridges on concepts for extended spans. This seminar will be on April 24th and 25th in Atlanta, Georgia. For more information and registration, please see the link that is on the screen. Note that registration closes on April 1st. Another event that is upcoming is the International Bridge Conference, the IBC. This is an annual event that is sponsored by the Engineers Society of Western Pennsylvania. This year, it will be in San Antonio, Texas, from June 3rd to June 5th. And for more information and registration, you can see the link on the screen. That takes us back to our own news for the IBT ABC UTC. Our next monthly webinar will be on April 18th. The presentation will be on UHPC Link Slab Design and Construction. Our presenter will be Jim Scarlatta, who's the Assistant Director of Structures Design Bureau for the New York State Department of Transportation. Please mark your calendars for that event. Also in April, on the 26th of April, we will have our quarterly research seminar. The project will be Insights into the Pull-Off Strength of Polymer Concrete and the Effects of Nanomodifications. This will be presented by our colleagues at the University of Oklahoma. That brings us to today's presentation. Our featured presentation is the accelerated replacement of the iconic Nashville Broadway Viaduct Bridge. Our presenters are Clayton Markham and Donald McCrary. With that, we'd like to turn the presentation over to Clayton.
Good afternoon, everybody. Thank you for joining us for this presentation. I hope the presentation will be informative and insightful. So I want to start the presentation with a quick story, a little bit about my family. Last year at Christmas time, we took a trip to a fun place here in Tennessee called Dollywood. It's a theme park where there's roller coasters and other fun events that you can do. One of the big things about this trip was that one of my sons had never been on a roller coaster. And so I really enjoyed wooden roller coasters. And so I was very much encouraging him to ride with me and experience the joy of a wooden roller coaster. I talked him up throughout most of the day. It took some time for him to build some courage to get into that the mode for riding the roller coaster. And here in Tennessee at night, or in the winter, night comes a little bit sooner than it typically does in the summer. So as he built up the courage, it took a little bit longer. And shortly after dinner time, he finally decided he was ready to go try it. So it did end up being dark. We got in line for the roller coaster. I was talking him up throughout the entire time, encouraging him, saying it's going to be fine, you're strapped in, there's nothing to worry about. We start going around the roller coaster and we make that first curve, and I have the expectation of kind of going up a little bit, catching the chain and going up the roller coaster, encouraging him the entire way, and then going off on our adventure through the roller coaster. And this particular roller coaster does not do that. You go around the corner and it actually accelerates you up the hill and does not slow down from there. So needless to say, he started screaming because we were not fully prepared for that. I started screaming a little bit because I was not prepared for that. And we pretty much screamed the entire way, all the way back. And that ties into this because that occasionally feels like what it's like to do one of these super accelerated projects. Everybody's expecting to kind of slowly creep up and get going. And it doesn't necessarily happen. It takes off. Not everybody's prepared for it, and somebody ends up screaming. But in the end, it turns out really well. So hopefully that's a little bit of experience that you'll get as we walk through this project, is what we felt as we were going through. So project location, this project was in Nashville, Tennessee. You can see here under the star that's there on the map. It was in downtown Nashville. So here's a map of the Nashville area. If you look, here is our inner loop that we have around downtown Nashville, the interstate loop. The project here is this red line is where the project is located. So really right in the heart of downtown. We have our central business district here just to the north, our lower Broadway entertainment district, which is really a big tourism attractor. Off to just to the south of the project is a really developing area called the Gulch. And then we have our medical and business district, West End, out this direction. Zooming in a little bit closer to the project site, you can see some of the more technical areas or more details around the area. One thing I want to highlight is some of the constraints for the project. So this building right here is the Union Station historic, right now it's a hotel, there's a historic Union Station train station. Just to the other side of it that you can see here in this building is a brand new Grand Hyatt Hotel. And our bridge is constrained in that it fits nicely right in between those two structures. Also has other constraints such as the railroad tracks that you can see running underneath. Just a few of the constraints that we faced on this project. A little bit about the history. So this bridge was originally built in the 1800s. It was then replaced in the 1940s. The original bridge, the 1800s bridge, was affectionately referred to as Old Shaky. That's not the one that we replaced in this project, but we actually replaced the 1947 bridge, due to it being at the end of its lifespan. It had been through 2 rehabilitation projects already, and it was really time, especially with the surge in growth that Nashville is seeing. It was really time to replace that before the project became even more constrained with additional development. This picture here to the right really shows some of the features that we have that you'll see a little bit later in the presentation as far as aesthetics on the bridge. Really played some key influence into that. So why did we need to do the project? Well, the project was near the end of its life cycle. The clearance over the railroad tracks was really substandard. It was enough to maintain it, but in order to improve safety, we increased that clearance over the railroad tracks. We know it's a gateway into downtown. It really feeds our lower Broadway district. As I said, is a really strong tourism attractor. And we knew that construction time on this bridge was going to be crucial. Because of the type of structure it was and the location it was, phase constructing really made it very difficult for a long-term impact in the area. So with that, we chose the CMGC, or Construction Manager General Contractor Delivery Method. And we really wanted to see what opportunities were available for us to accelerate the bridge construction. So what CMGC is really we bring on a contractor early on in the process to give us insight into how do we build the project, how do we approach the project, what innovations can we use, are there new materials, different construction techniques, different methods that we can use to improve the process and then adjust the design towards their capabilities to help with efficiency. Along with that, we also get opportunities to price different design decisions so that we can make the best decision for the cost of the project and the design of the project as we go through the design. And then also we get feedback and discussion on what different design options would do as far as schedule, what is feasible, what's not. And most importantly is we get to talk about risk with the contractor. We get to identify risks. We have the opportunity to work through mitigation of those risks, to reduce them, and then also have the conversation about who should best own what risks so that it is best shared with whoever is best able to maintain or mitigate or hold on to that risk. So for this project, we knew time was critical. So we allowed for an 8-week full closure of the Broadway Bridge. With that, detour routes were pretty critical, knowing how, well, if we're going to close this down, how are people going to get around? So we came up with feasible detours for the area to maintain access to that. One of our main goals was to maintain access to the local businesses in the area, in particular those significant hotels that are immediately adjacent to the project, which actually played more into the project that we'll discuss a little bit later. At the end of the 2-week, or at the end of the 8-week closure, the contractor had to have the structure back open to 2 lanes in each direction, or 4 lanes total, at the end of that 8-week closure. You can see here the one other piece that we had to account for, this green line here, accounts for the pedestrian traffic, as this is a significant pedestrian route as well. When we talk about stakeholders, this project had several stakeholders. Key importance of these are CSX and Southwest Value Partners. So CSX obviously owns the railroad tracks underneath the bridge. Southwest Value Partners was key as they own or maintain the 2 hotels on the eastern end of the bridge. There are others. Highwoods is another property owner who was key with this project. NDOT, or Nashville DOT, was absolutely critical in coordinating the design with them and coordinating the construction activities right away. There were some significant utilities, as referenced here by AT&T. We'll get more into those details here in a few minutes. And then also maintaining communication with all of these stakeholders, not only early coordination, but also all the way through construction. So there's constant efforts to talk with these utility owners, get their observations, get their thoughts, and incorporate what we could into the project to minimize impacts and really facilitate the project as best as we could. Project schedule, our pre-construction, we brought the CEM, the construction manager, on at the end of 21, early 2022. Right away and plan design really occurred from the January of 2022 through April of 2022, with construction design following on through June of 2022. During that time, right at that April time period, the right-of-way and utility coordination process kicked off and actually ran into March of 23, which we'll talk about in a few minutes. We did have, or were able to accommodate some early work packages with this project, and that allowed us to facilitate some early procurement of materials and preparation activities for the closure. And then we ended up with a GMP contract, and negotiations ended around the October-November timeframe of 2022. We did have some challenges with our schedule. So we initially started with this scenario, the one we dubbed the miracle. That was our ideal, what we wanted to do with the project. So we really wanted to be done with design, all of our pre-construction activities around the August timeframe, which will allow us the winter months to prepare for the closure and then have the closure window outside of main events or the main tourism season of the summer, where we have activities such as the CMA Festival, Independence Day, Labor Day, where we see significant increases in visitors into the Nashville downtown area. So We got into the project, we found out that we were not going to be able to meet that schedule. So we started looking at what are the options for us to be able to still hit our goals of not impacting the downtown area too significantly, and then also deliver the project as timely as we could. So option one was the pause button, where we took more of a traditional delivery path. We decided that was not in the interest of the project or the Nashville area. So we looked at other options as what we could do. One that we ended up going with was what we dubbed affectionately as risky business. It's risky in that we're still moving forward with what we can while we're continuing the utility and right-of-way coordination. That process, so if you look at the risky business schedule, that really actually reflects what was the true schedule of what the project actually occurred. So we were planning this early on, and it fit just within these timelines. So we were allowed to do some early work while we're finishing up the right-of-way and utility negotiation process, which ended in May 8th of 23. And then we had a few months of prep time, and then our closure window fit nicely in between Independence Day and Labor Day. For project budget, we originally started with a $50,000 budget for roadway and bridge construction of the project, or $50 million, excuse me. We did not, and that budget did not necessarily account for utilities. And the more we got into the utilities, the more we found, especially being in an urban area. With our CMDC process, we walked through various iterations of those price points. We get to have those cost negotiations and discussions as to what it is. You can see a bigger jump here. That's where those utilities and some other costs were captured kind of later on in the process that we were not necessarily aware of at the beginning of the project. Our process is that the contractor gets 3 attempts once we go into those final guaranteed maximum price, or GMP, negotiations. And that has to be, the contractor has to be within 10% of the department's internal estimate, or we do hire an independent cost estimator, or ICE consultant, to work alongside us to prepare an estimate as well. We ended up at a just under $72 million cost for the bridge. 23%, about a quarter of it, is the roadway approaches on either side of the bridge. About 47%, or about just at half of that cost, was the bridge itself. And then there are other utility and other indirect costs and some contingency that were included as well. When we look at cost per square foot of the bridge, if you take the whole cost and you do it per square foot of the bridge, it's about $1,290 per square foot, which is really, really high. For the bridge only, if you only look at that cost, it was about a $618 cost per square foot, which is still above what we typically see in the $250 to $350 per square foot roughly range. So it was a little bit more expensive, but as we get into some of the constraints and the details throughout this presentation, you'll see kind of what contributed to some of those costs. So critical elements of construction. Being in an urban setting, there was lots of lack of access and other downtown construction. I mentioned that Nashville is really a booming area, and so there's a lot of tall buildings being constructed in the vicinity of the project, so we had to coordinate with those. Adjacent stakeholders were really critical, coordinating with CSX and the railroad tracks. Don, in a little bit, will go through some of the details on this, but there were some active AT&T utilities that had to maintain and remain in place as the old bridge was demolished around it and the new bridge was put in place without moving them. So because of this and the accelerated work schedule, we looked at early work packages to allow some of those long lead time items to be not impactful to the schedule. So bridge girder procurement, precast panel procurement. There was some early utility work to get some of those early utilities out of the way as timely as possible. And then there was also some of the critical yards, laydown yards, in preparation for the work to be done. That work was done early as well. Pre-closure work, so this is the work that occurred before the full closure. Early utility locations, and this took place between January and June of 2023. The substructure construction was completed, so the idea is to build as much of the substructure, new substructure underneath the bridge as we could before we went into the full closure. So we were prepared and ready to just replace the superstructure. With that, there was some partial demo as much as possible for the existing superstructure, and traffic was narrowed down into a similar pattern as what would be opened up at the end of the full closure. So the closure window was from July 7th, just after the Independence Day holiday, to September 1st, just before the Labor Day weekend. There is a little asterisk there. We'll talk about that here in just a second. But you can see in the images below, kind of the phasing. It would be to demo the old bridge, place the girders, the new bridge, place the precast panels, and then clean everything up. And that all occur within that 8-week time period. However, we had a few months before we got into the closure period, the Southeast Conference football media days were announced that they were going to be in Nashville for the first time ever. And with that, they said, hey, we're also going to hold it right here in this Grand Hyatt Hotel, the one that you've seen in some of these previous pictures. Oh, and by the way, these are also going to occur in about the second week of your full closure. So with that, we really had a big challenge of how do we facilitate this major event, especially for the city of Nashville. How do we accommodate that? And we were able to work with the contractor to be able to essentially shut down any noisy activities in the area as they were broadcasting live from that building right next to the project. We did end up extending the closure period about a week in order to accommodate for that shutdown period. Look at a few construction pictures here. We'll cover more a little bit later, but just some details. Due to some of the constraints, there was some time-consuming operations. So these are the AT&T conduits that had to remain in place. This is a procedure to pull those out one piece at a time. Where we had to, in particular over the railroad right away, big sections of the bridge were pulled out in chunks at a time. And then where we were able to, in order to facilitate speed, we demoed the bridge by traditional means. The superstructure steel was about 70 girders total. They were in a simple span configuration, and there were some significant efforts. You can see here the AT&T conduits that were suspended in place and then transferred over to the new structure as those girders were put in place. Very, very innovative feature on this project. Precast panels, we had about 276 of those. They were about 8 feet by 25 feet and about 25,000 pounds per panel. And those were all set really timely and really without any incident. Following that, once all those panels were in place, the contractor began with closure pours, and then in order to get a good smooth riding surface, they had to grind through some of those in order to get that smooth ride. We have an epoxy overlay just to seal and protect the deck. And then we were, with that extended time of closure and the pace at which the contractor worked, they were able to go ahead and add and complete both parapets on both sides and both sidewalks on both sides of the bridge, so that we would no longer impact traffic significantly or have to once the closure was open. And then also roadway tie-ins on both sides were completed in that time. And we were able to open right on time and without any delays and with a little bit more work than was originally planned to be accomplished during the closure. And with that, I will turn the presentation over to Don.
All right, thank you, Clayton. All right, just go over a little bit about on the bridge design and the constructability of it. So originally, before the contractor came on board, during our planning stages, we came up with a 30% layout of the bridge, just so that just to give something to the contractors to sort of throw in their RFPs for. And so originally, the existing bridge here is an 18-span steel structure. And so early on, we ended up going with just during the preliminary stage, a 10-span pre-stressed concrete bridge. So some of our factors, again, like Clayton mentioned earlier, so the construction schedule was very key to the success of this project. And then also with that entails, some of the construction approach, the railroad clearances, the adjacent buildings, the Grand Hyatt and the Union Station on both sides of the bridges, and then of course the existing substructures and their foundations, and also the utilities. So all this put together was sort of the driving factors into trying to figure out a different configuration that would help speed up the process. So once the contractor came on board, which was Kiewit, we had collaborated with each other and came up with a new configuration that would work well with them and with the 8-week closure period that's going to happen. And so the new configuration we came up with a 5-span steel girder bridge, and by doing that, we eliminated the middle pier here, which fell in the right of way for the railroad. And by doing that, crash walls are eliminated, and then your permit are reduced for the railroad. And then also here in the shaded area here, we actually shortened our bridge, and we used some lightweight cellular fill to fill in these couple spans here, which I'll go into next and talk about what we did on that. So just to give you a little cross section of our proposed bridge here. So the existing bridge length was about 702 feet. We ended up shortening it to 564 feet. Main span's 140-foot span, steel girder, about 100-foot wide with sidewalks on it. And then we ended up utilizing full depth deck panels, and which had a 3/8-inch thin overlay. And also too, with that, we actually on our deck panels, we allowed for a 1/2-inch tolerance for grinding. So let's talk about what something unique that we ended up doing on filling these two existing spans here. So originally, it's just a little bit of history on this area right here. So Tennessean, which used to be a newspaper company that ran in the state of Tennessee here. So they actually utilized these two spans here, and they actually built like walls underneath this. And so they essentially just utilized these two spans, and what they would do under here, they would hold their newspapers and things like that. And so we just TDOT agreed, and that necessary that we didn't really need to use none of this space here. So we ended up converting these two areas with some lightweight cellular fill. And what that does with the lightweight cellular fill, it allowed the contractor to place this lightweight cellular fill while the existing bridge is still being open. Just a little schematic here on what we were ended up doing. So it's the lightweight cellular fill is poured in 3-foot lifts, and the good thing about this lightweight cellular fill, it's a self-supporting fill. So the NOAA didn't have to had no kind of walls or anything like that to hold this back. And another neat thing about this is the existing steel girders there, we actually left those in place. So the contractor didn't have to excavate those out and take any of that stuff out. And so we actually brought that up to grade and then just poured asphalt on top of that. There's just a picture of the construction there with the being so again, like I was mentioning earlier, and they're placed in 3-foot lifts. Let's go talk about some of the vertical constraints on the existing bridge here. So as Clayton mentioned earlier, we had a lot of constraints here that we had to deal with. So we had the Grand Hyatt here, the Union Station Hotel here, and then of course we got our railroads here, which again, they were substandard to begin with. So to bring that up, we couldn't, so we couldn't really raise the grade as much as typically you would to meet the 23-foot clearance. So there's different tie-ins here that we had to go in. So here's the Union Station tie-in. We had to tie in with their front entrance right here. And then of course on the other side here on the Grand Hyatt, the same situation here. We had to tie back in to their front entrance and sidewalk. So with that being said, that just limited us on our vertical clearances on how much we can raise our profile. So just to give you an illustration on our profile here. So the existing profile didn't have, is almost flat, had a little bit of a curve there. But as you can see here, so here's our existing railroad clearances, which were substandard to begin with. And so during the early on process, TDOT engaged with CSX, and they came up with some values here which CSX agreed on, and that's what we ended up raising our profile to. And so now you can kind of see now we've got a pretty significant hump in our bridge. And here's just the construction, just to sort of give you an illustration here on that curve, on how defined that vertical curve is. Let's go discuss a little bit about our precast deck panels, some details on that. So we ended up using a 10-inch full deck precast deck panels, and again allowed for 1/2-inch tolerance for grinding. So a couple key impactful decisions on these, I guess sort of the layout of the way we laid these panels out. So traditionally, and what we'll do in TDOT in Tennessee is we'll usually try to use longitudinal panels, and what that does is just makes it easier to consolidate your concrete over your beams. But as you've seen on the previous picture on how our vertical curve was, we were, if we use longitudinal panels, we would have to, the amount of grinding on these panels would have been significant and just time consuming. And so we ended up going with the use of transverse panels with shear pockets to make the deck composite. I'll just give a couple details here. So we had the longitudinal connection with the panels. They're tied together by by projecting bars with closure pores. So they're made composite and then our girders are made composite with these shear pockets over our steel girder shear studs. And you can kind of see how pretty amazing how that we don't have, our pockets here are pretty tight, so our tolerances were real low, or tight tolerances. And as a contractor was setting these panels, we didn't, I think they had over 270 something panels, and they set these panels without any issues whatsoever. So it's kind of pretty amazing on how closely and well that these that fit in. So again, as I mentioned before, we had so we prefabricated 276 total panels here. So as you can see on this layout here, so just due to our geometry, you got the Union Station here, which so the bridge is sort of forming around it, and then on this side here, there's a parking lot as well. So with that, and just with the other with the different cross sections that we had, you can kind of see. So we had 60 different configurations of deck panels, and then just our staging site was just right off the about a half a mile from our bridge. So that made it pretty convenient. Just sort of discuss the deck drain system. So we had to have a closed drainage system within our bridge. So we just typically use the TDOT standard deck grates. What was pretty interesting on this, originally we were going to have these deck drains casted with our deck panels. So we got to looking at it, and we actually made our deck drains in the closure pores, which saved time for the fabricator for the deck panels, and made a little bit easier for the contractor to construct these and get these deck grates at the right grade. So I'll just sort of discuss some of our design on how we ended up going with a simple span configuration on our steel girder placement. So traditionally, everybody knows that you want your steel girders to be continuous, and then you'll have spliced over the bents there on either side, and then you'll have field splices and field bolts to to connect those girders. So looking at that, and again, with our schedule being, an 8-week closure, and with being a 600-foot long bridge, and having so many girders here, contractor felt that it was going to be really difficult, or just as far as trying to get that in time to field bolt all our splices. We've got 4 bents, so to get all these splices fit up and to get those girders tied together, it was going to take a significant amount of time in doing that. And so our solution was to utilize simple span girders. And again, because of the vertical constraints that we had, and with the railroad, we didn't have very much depth to work with. And so with that, as you can see in this picture here, we had very shallow, inefficient girders. So our total depth was probably 36 inches of total depth there. And so our span to depth ratio was very high. And with that, our biggest challenge was how do we create, try to limit our live load deflections. And so again, that was so one of our solutions was to we made a simple span, and we were going to make our continuous for live load through the use of concrete diaphragms, which I'll go through and talk about that through here in just a second. And then also too, a unique thing that we did is for our flanges, we utilized high performance steels, grade 70 steel. And the reason for that was we wanted to limit our flange widths because of the adjacent hotels on there. Without going to grade 70, we was going to have to use some really big, large flange widths. So just a little illustration here on how the simple dead load and make continuous for live load. So girders are simply supportive spans, and when the deck is cast, which is represented by the dark blue line there, and the girders are tied together over supports using some diaphragms, and then after the placement of the panels. And then once that is done, continuity is established with the diaphragms after the panel closure pours, and the concrete diaphragm is cured. And then just any additional loads added, after the continuity establishes, will produce some continuous load effects on the spans. So again, some of our challenges here with this. So again, with this union station being set right here, we essentially had to, traditionally you'll have, your girders sort of line up, which they do in these several spans over here. But when we get to this one span here, because of this union station here, we had to push our girders out a little bit. And so we had to have it, our girders are offset here. And so with that, due to that offset, we created some very large torsional effects in our diaphragms. And so to account for that, well, we utilized CSI Bridge. CSI Bridge was a finite element modeling to get our torsional effects, our moment there, and design our concrete diaphragm to that. Just talk a little bit about on why we chose our continuity with the concrete diaphragm. So traditionally, with what TDOT does is we'll have splice plates over connecting the two girders there to create that continuity. Again, being schedule being the biggest driver here, just trying to bolt up all these splice plates with these girders, it was just going to take a significant amount of time. And so we ended up utilizing through just doing some research, which FIU was done, we ended up using a concrete diaphragm, and so we threaded bars through our ends of our girders and then tied them with stirrups. So here's a detail right here through that. And so that moment is transferred through, via the concrete compression. And then we utilize drop-in reinforcement in our slab to provide for that tension in the slab. Talk a little bit about the substructures and the footings here. So as Clayton mentioned earlier, we did some early work here. We were essentially building our substructures while the existing bridge is still being placed or still being in place. And so by doing that, you know, traditional H piles, it just didn't didn't lend itself to the situation because of our combined space and our limited overhead. So we ended up using, so the solution to that was we ended up using micropiles for that. So some of the benefits of micropiles, you know, they work good in compression and tension. They're easily installed in very confined spaces, as you can see here. Minimal vibration and noise or you know, to the surrounding areas, and which was key because of our adjacent hotels. And then they are of, you know, very high axial load capacity in the micropiles. Our abutments, we just standard closed abutments on rock on one end, and then they were on micropiles on the other end. So the rock was varying pretty significantly. So essentially half the bridge was spread footings on rock, and then half the bridge was on micropiles. Our bents, just standard 4-post column bents, again with spread footings and micropiles. So again, the thing here is we had you know, built the substructure up to about 6 inches below the existing girders, and then once the superstructure was demolished and that closure started, we came back with a second pour, which brings that up to the elevation to the correct girder seats. Our bearings consisted of reinforced elastomeric pads. Just a little real quick on the bridge rail and some of the sidewalk lightings that we introduced in this bridge. So we tried to, so Union Station here, you know, is a historic station, and so we sort of tried to mimic a little bit and try to pay homage to the to Union Station Hotel. So as you can see here, they had, you know, several arches in there. So we tried to mimic that in our rail, and so we ended up having, as you see here, we had those arches in our rail. And then on the inside of the rail, we ended up using some pedestrian LED lighting to allow for the pedestrians, since this bridge is very heavily traveled by pedestrians. So as Clayton mentioned earlier, so our AT&T lines here, that's probably one of the most critical aspects of the project. So some of the challenges was these lines were critical communication links of Nashville. So relocating them was going to be somewhere between $6 to $10 million, and with that relocation, it was going to take, you know, over 4 to 5 years to complete that. And so obviously that just didn't work with our schedule. And so, you know, another challenge was these lines had to stay in place without any movement whatsoever. So essentially, just think about, we had to build our bridge, you know, around these AT&T lines. And so some of our design solution, we came up with an innovative temporary false work and a sort of a custom construction approach to this. I'll sort of just walk through on what we ended up doing, sort of the schematic of it. So pre-closure, what the contractor done, we come in here and we conduit was abated, and they were replaced with some PVC split duct. At that same time, the contractor would install these temporary brackets here, and what that would do was it would take the load off of the essentially hold these conduits up with this one girder. So once closure was started, the existing bridge was demolished here, and so as you can see here, so we came up with a sort of a pretty unique false work and temporary temporary shoring and things to essentially hold up this one existing girder and these AT&T lines here. So there's the existing bridge was a steel frame bent, and so you can see how we utilize that existing frame bent to hold this girder up and these AT&T lines. So once that was done, they came back and installed the new girders on each side of the existing girder here. And then contractor would install, which they call some needle beams, and then that would connect and essentially would hold these existing lines up so that we can take this existing girder out and place a new one in its place. So once that was done and the new girder was installed in its place, and then came back with some permanent brackets for the final bracket system to hold up these AT&T lines. And as you can see here, here's just the finished product of it, on how they completed that. All right, I'll just real quick just go through some construction photos here. Here they're demolishing the bridge here, and as you can see, here's the AT&T lines. Here they've got everything completed or demolished. I'm sorry. Here they're setting girders. This one right here, setting the deck panels, and then here's all the closure pours are completed, and they're just wet curing the deck. Here on the left here, they're doing their grinding of the deck panels, and then placement of the epoxy overlay here. And here's the finished product. And as you can see here, you can kind of see, how significant that, that vertical curve there is. All right, with that, I got a little video here, if it will play. It's a sort of a time lapse. Sorry for about the no sound on here, so I can sort of walk through a little bit. So here they're just demolishing the bridge here, placement, setting the new girders here, and then they're placing the deck panels. Again, it's just really amazing with all these deck panels and just the geometry of our bridge here. The contractor really had no issues with setting these deck panels. And they just fit perfectly like we designed them to, which is pretty amazing with the amount of how long this bridge is and just with the amount of deck panels that we had. Here they're grinding the deck and they're placing the sidewalks on the bridge, and then they're laying the epoxy overlay, and that concludes it.
All right, Clayton and Al, thanks a lot for a great presentation. At this point, we are going to let Paul Lyles, formerly with Georgia DOT, and Jogesh Kapoor to moderate the question and answer period. Paul?
Okay, thank you, Torrid. And Clayton and Don, yes, we do have a few questions that have come in, and there are some more coming in right now. And I think I can get them through about 1:54. I'm going to ask you guys to take over after that. The first question I have here is go through some design questions. The first one was, this is a pre-webinar question, was lightweight concrete considered for the bridge deck?
It wasn't. We entertained it if we were going to have issues with our girders, then that would have been something that we would definitely use, but originally it wasn't considered.
Okay. Then is the epoxy deck overlay the traffic wearing surface?
Correct, it is.
Okay. We had a few questions here in design, and I'll try and talk to them. It said, did you consider maybe steel boxes topped with concrete deck to form a module and using simple spans for live load and then continuous for, simple spans for dead load and continuous for live load? That's something that's considered sometimes in ABC.
Yeah, we did not. That's a good point. That may have been something that could have been considered, but we didn't consider that.
Okay. Do you have any idea on the relative cost of using the 70 KSI flanges, high performance steel versus maybe 50 KSI?
I don't remember right offhand what that additional cost was. I don't recall exactly how much additional cost it was versus the grade 50.
Okay. Then there's a question here about when you were doing it. Some people have said that the diaphragms maybe could crush when you do them continuous for live load. Some will put plates at the ends of the girders, the eye girders. Did you consider doing that?
We were going to, but we just took that into account in our concrete diaphragm, and since we had such a big diaphragm, we had a 4-foot diaphragm, and so it wasn't that concrete wasn't going to crush. So
Okay. I've got a few more construction questions here. What material did you use for the closure joints? Was it normal strength concrete or UHPC?
so yeah, I meant to mention that in our in the presentation, and I apologize for that. I just glanced over that. So we did look into using UHPC, but because of the pour rate and with the amount of closure pours that we had, the contractor didn't feel that it would be that they couldn't get all that poured within the 8-week closure period. So we ended up just using a standard TDOT's traditional higher strength concrete.
Okay, and then there was a question on vertical clearance about what was the impact on the final vertical clearance by choosing simply supported, then continuous for live load, as opposed to just straight continuous girders all the way through.
Well, that was the issue was just couldn't the contractor couldn't set their girders fast enough if we went with traditional continuous girders. So
okay, yeah, you showed that in one of your diagrams. That was pretty good.
Yep.
So then let me ask you some questions about the delivery method and then the ABC. First of all, when developing an urban project, you often struggle with balancing disruption avoidance with the cost of the disruption avoidance. And how has Tennessee DOT managed public opinion such that ABC methods are embraced by both the public and the contracting community?
Yeah, so we've utilized the CMGC. It's a really good question. We utilize the CMGC process and the ABC materials. We've used those very successfully in our downtown Nashville area to really show the motoring public that we are able to get in and do the work quickly. So we analyze what the cost of the material or the cost of doing the ABC technique would be, and we compare that with what the user costs are for the facility. And when that user cost outweighs the additional cost of using the ABC techniques, that's when we lean towards those. And when we see that we can gain some advantage by utilizing those ABC techniques to really reduce the impacts to the community around the project.
Okay, so you do that analysis. That's interesting. Okay, on the delivery method, Tennessee DOT appears to make extensive use of alternative delivery methods. Can you give an approximate percentage of projects that use alternate delivery versus traditionally design bid build?
So we are actually a younger state with the alternative delivery. We are growing our alternative delivery program. We've been doing it since 2014. We've delivered about 15 projects between design build and CMGC. Overall, cost-wise, that equates to about 1% of our construction costs over that same period. So it's really a pretty small portion of our delivery, but we are looking at the opportunities to grow our division, grow alternative delivery in the state of Tennessee, and increase that percentage, but it won't ever overtake our traditional delivery method. We don't expect.
Okay. Is there a decision-making method for determining the delivery method that for Tennessee DOT projects? And how do you choose between design bid build, and CMGC?
So we're in the process of formally documenting what that process is. We do somewhat rely on the projects that we have done historically and what those entail. We're also evaluating the use of FHWA's case tool and how that applies. It gives recommendations based on answering some questions for delivery methods. Some of the keys we look for are need for acceleration or urgency on the project, complexity of the project, what are the impacts to the users and the locals around the project, are all factors in deciding between alternative delivery and traditional delivery. And once we've made that distinction, then we decide on if it's a candidate for alternative delivery and it would benefit from collaboration from a contractor or expedition through the alternative delivery process. Then we look at different technicalities of the project. Are there significant third-party impacts? Like on this project, we had significant stakeholders, utilities, right-of-way, railroad coordination. We look at those, and then we make a determination on what is the best delivery method that fits within that project, or that project fits.
Okay. Now, given your use of the alternative delivery, do you have resources available for reference by other state DOTs? And if yes, could you describe the resources?
So we are developing, as I said, we're a developing section. So we are in the process of developing some standard guidance and processes. We do have some resources on our alternative delivery webpage for Tennessee DOT. We're looking, hopefully in the future, to have more resources put out there just to be available for other states and our contractors as well.
Okay. And then does Tennessee DOT develop the CMGC request for proposal with internal resources, or do you make use of consultant augmentation?
So we have done both. We have used consultants to help us really get started, help us understand what we're doing. We've also developed some of those internally. As a part of that, developing our guidance process and guidance documents, we are moving towards a more standardized type template approach to developing those RFPs for more consistency in how we write those RFPs so that the proposers have more consistent expectations. As part of that, we do expect that workload to be carried more internally in the future. Not to say that we won't have a project specific where we need some outside assistance to help develop those documents as well.
Okay. And the same question for project execution. Do you use internal resources or do you use consultants?
So we have recently grown our division. We now have project managers in each of our regions, as well as a regional manager to help facilitate and oversee these projects as we get more and more projects delivered by alternative delivery. So we do use internal project managers, but for many of the other resources, such as design consultants, owners representatives, CEI, construction engineering inspection, we do utilize outside consultants for those activities as well.
Okay. We've got a bunch of questions more that came in during the question and answering part. There's a whole bunch of them here. So it's just about 5 after. I'm going to get Jugash to come on and ask some of these questions. Jugash?
Thank you, Paul. The first question is, did the precast panels sit directly on top of the flange, or was there a haunch?
There was a haunch. So we had a 4-inch haunch, and then we utilized some a non-compressible material to set that on top of.
Okay. And how were the closures formed underneath?
That I don't know specifically what the contractor used. I'm assuming they used some sort of soffit or something. So I don't know exactly what the exact material they used to form it up with.
Okay, thank you. Continuing with the same question, there was another statement or a question that is asking, does the bridge have a parabolic crown? If so, how is this achieved?
Yeah, so we had a 2% crown, I guess. It was, so the good thing about it, we actually had that crown point was in our closure pour. So they just so it wasn't in our deck panel itself. It was in the closure pour itself. So
okay, thank you. Next question, how much deeper were the simply supported girders than if you had to be able to design continuous steel girders?
I'm sorry, I didn't get that question again.
The question was, how much deeper were the simply supported girders compared to if they were designed as continuous?
I think if I'm understanding you, Craig, I think as far as the depth of our girders. So I think just depth. I think either way we still would have been shallow on our girders, regardless on how we designed it, simple span or traditional continuous.
Okay, and the next question is asking, did you use precast panels instead of cast in place deck because of time pressure?
Correct. Yeah.
That's part of the ABC process.
Yeah. Correct.
Okay. Next question, was anything unexpected encountered during construction?
I'll say yes. We did find a couple of utilities that we were not necessarily expecting, and then really the biggest one was the SEC media days that occurred at the adjacent hotel. That was definitely a big unexpected event that had to be accommodated.
Okay, thank you. Were live load deflections limited to L over 1,000?
Yeah, it was. And that was one of the reasons why we had to find a way to make it continuous to control our deflections there. But otherwise, we would have failed in our live load deflections.
Okay, thank you. Next question, were precast bend caps and columns considered to save time?
It was. So early on, we actually talked about using precast substructure caps and things like that. But as the project kept going and we realized that we could build the bridge, build the substructures while the existing is still in place. So we sorted through that option out.
Okay. What was the relative construction time spent on different components of the bridge? Example, demolition, foundation, substructure, and superstructure.
Clayton, I don't know if you know that better than I do.
It's a loaded question. Yeah.
Yeah, we may have to get back with that, but in general,
Okay.
The substructure really just was able to take several months to be installed. It was built more traditionally with traffic maintained. So really the substructure would follow a more traditional timeline, whereas the demolition and the superstructure placement was much more accelerated than a traditional project.
Okay. Were vibrations during construction a concern to the adjacent buildings?
They were a bit. We did get some feedback and some concern in particular from the hotels about the vibrations, and then maybe more than vibrations is noise that was occurring because this was a 24/7 operation. So they were doing, at least through a short period, a demolition overnight. But through our early coordination with not only the two hotels, but other surrounding areas and our good community relations team, we were able to handle those questions, resolving the issues from those pretty quickly.
Okay, thank you. What type of micropiles were used?
I think they were 9 and 5/8 inch micropiles.
Okay. And the next follow-up question to that is, what was the idea behind using micropiles on the substructure? Because you had limited overhead clearance.
Yeah. So the main thing was just our limited overhead confined space that we had. So we were very limited on our space. So.
Okay. All right. The last question I have is, which modeling software was used to analyze and design this bridge, and was the vertical profile considered in the model?
So yes, it was. So we utilized CSI Bridge, and we also utilized Leap Steel to design our steel girders. So.
Okay, that completes the list of questions that came in during the presentation. I thank you both for answering them, and I will turn it back to Adirondack.
All right. Thank you. Thank you, Jogesh. Thank you, Paul, for moderating. Thanks to our speakers. Excellent presentation, very informative. So on that note, we will conclude our webinar and hope to have everyone back with us next month. And please, again, don't wait until the last minute to submit your abstract. Even though the deadline is April 12th, please send your abstract a little bit early. That will help us to in the planning and organization, the review process, and so on. So on that note, we will end the webinar and hope to have you back with us next month. So long.
Thanks, everybody.